your paper 21st January, second shift, right? Already I do 21st January, second shift, memory age. Student data can be vary, right? So keep it in mind. Student, have a look at the question number one. What question says? A battery with EMF and internal resistance R is connected across a resistance R. The power consumption will be maximum. Students, this question is repeated by NTA more than two times, right? I guess this question is asked by one of my students, Karthik. He appeared in 2018, right? So, student, it's a very common derivation of the classroom. So, what's answer, students? That is, I can say options number first. R is equals to R for maximum power, right? Now, student, have a look at the next question, student. So, what question is, student? Keeping the significant figures in what view? The sum of the physical quantities. Student, there is, I can say, a few digits is mentioned. Here we have to find what is the beta. Here we have to find what is the final values. We have just perform sum, means summation of these all physical quantities. Students, for solutions, what I can see my idea for this, you can add these all. So this is what 52.01. Next beta is 153.2. Next students, 0.123. Just simply you can add. So what you can see, this is 3 plus 2, 5, and 5 plus 5, 10, and 1, 1, 2, 205.33. But students, if you remember class concept, if you remember class concept, students, then what you can say, students, what is the rules to add significant figure? Because now uh, I means I added, there are three quantity, 1, 2, and 3. In these all, you have to find which quantity has a less significant figure after decimal. So I'll repeat. This is the terms and conditions to add significant figure for addition rule, right? What I can say. So students here, just you have to find, because this is a physical quantity one, physical quantity two, and physical quantity three. In these all, students, you have to find which one has a less significant figure after decimal, right? You can see there is what? How much two? Here is what? Three. What is less? That is 1. So your answer is what? I can say, suppose right answer correct. This is 205.3. Hence, options A is correct. Hence, option A is correct. Right, my dear? Okay. Now, students, have a look at next questions. So, student, what is the next questions? The energy, students, the energy of an orbit of Bohr's hydrogen atom is 0.004 E in electron volt, where A is the energy of ground state by hydrogen atom. If L is the angular momentum of E in this orbit and H is the Planck's constant, then we have to find what you have to find, students? 2 pi L upon H. Students, data can be vary. It's memory based questions, right? So keep in mind this basic concept. Students, for this condition, what I can do, Bitaji, I hope all of you remember the basics points for solution students. No, there is what n times you can take consideration. There is, I can say, ground state, then first excited state, second excited state, third, and you can say like beta, it's a so on, right, my dear? Okay, initially, beta, what is the energy we can take at initial at ground state? That is what students, it's minus E naught, right? What we can take finally? This is what, my dear? E naught upon n square, right? I can see beta. Students, actually, I got delay paper from I can like students, so that's why I got delay. Now, students, this is E naught and E naught by I can say n square, right? Then beta, what you can say this energy because they mentions energy at what Bohr's atom. So, student, you can just equate this two, right? So, student, you will equate. Then what you will get? This is minus E naught by beta g n square is equals to minus 0.04. This is what beta g? This is E, not you can take. Now, students, for this condition, you can take this is E naught finish, minus minus finish. You can take my dear, this is n square. You can take two decimal down. So you can write this is 4 by 100. So with I can say 1 by n square, that is 1 by 25. N, students, this is what? N, we got n is equals to what? You can say 5. But this is not our answer. What they ask, 2 pi L upon H. We have to find this one. I can say, beta, this is step 1. My dear, step 2. Student, this is. I'll work. I wanted to write step 3 over there. Student, we remember what is the angular momentum. What is angular momentum? This is L is equals to, I hope you remember everyone, beta. N into, it's the what postulate number 2. NH upon 2 pi. So student, what is n? Already we found that is 5. So you can say L is equals to 5 times of h upon 2 pi. So what beta? We wish to find basically what's the things? 2 pi L upon h, which is equals to 5. What your right answer? Student, this is options first is correct. Right, my dear. Okay. Now students, just have a look next questions. What question says? The kinetic energy of a simple harmonic oscillating with angular frequency of 176 Hz. Okay, student, they mention. Student, do underline, right? During paper solving beta, just be remember you have to students underline few words. I can see for you not possible, it's the screen, but try to write on the paper. The frequency of the simple harmonic oscillator they're asking. They are asking what is student frequency of simple harmonic oscillator. Students, I can say about this one, this question. I in the classroom I repeated multiple times, and I pressurize also. Student, be remember this question you will get. Be remember this question you will get. You know how this is very simple question, beta. Okay, students, just we'll go through because we want to find oscillator frequency. Beta, we can take there is space is available. Okay, I'll use here. Students, I can say for this condition, what is the point? Students, I'll use that is VT relation. I hope all of you remember. V is equals to A omega, what students cos omega t. This is, you can say, VT relation. Students, I hope all of you remember VT graph as well. So students, here I'll write, this is what VT graph. So cos graph beta always is started with +1. So you can see my here, this is the graph like this for complete one cycle. Now students, I can say for this student, uh, this time period is what? Basically T only, right? This is T only. This is T beta, you can write, this is what my dear? It's T by 4. It's a T by 4. Students, you can see this is what? T by 2. This is 3T by 4 and this is T. Students, now you can see for one complete cycle, this is what VT graph. This is what students VT graph. Uh, Student, this is what I can say. This is the VT graph. V as a function of time t. Right. Now, students, here I have to find what beta kinetic energy expression. You know, kinetic energy always be positive. So you can make diagram like kinetic energy. This is students, always positive. So we'll go like this. Now you can say for one students, for one complete motion of I can say particle, the kinetic energy what? Completed two cycles. This is the point basically we have to understand. Kinetic energy beta what we can say? This is what basically two cycle. So students, for these questions, this is a very repeat question in the classroom. I said, if I can say your frequency of oscillation is F, so what is the frequency of oscillations for kinetic energy and potential energy, which is equals to 2F, right? So beta already frequency mentioned for us. Students, you can write over here. This is twice of frequency, which is what, my dear? 176. So this is mentioned in the questions. This is 176. So simply you can just solve. You will get this is what? 88 hertz. Any option is this? Have a look. Student, this is any option? Yes. This is, I can say, options number Bombay. So question is not of age, right? It's a solvable questions you can do. Next, I can see in the paper hole beta, that is patience. So what is the next question, student? Have a look. Next question. This is question number 5. What's the questions? Student, the RMS speed of oxygen molecules at a 47 degrees Celsius, at a what, students? 47 degrees Celsius is equals to that of hydrogen. It's very simple, you know. The classroom, I repeated multiple times during classroom program. Students, we remember this question definitely will get. Students, according to, I can say statement of questions, according to questions, student, I can write V RMS of O2 is equals to beta Z VRMS of H2. Simple. VRMS beta, what I can say, you can write this side is student. This is 3RT upon M is equals to beta. This is 3RT by M. You can see, sir, what is things we have to find. Students, temperature of oxygen mentioned for us, that is 40 degrees Celsius. You can convert beta. Let us suppose this is T1. You have to convert. What beta? You can say this is 47 degrees Celsius plus 273. So you will get this is 7 plus 3, 10, and 7, 4 plus 7, 11, 12, and this is 320. Right, beta? So this is, I can say, which we calculated in Kelvin only. This is in Kelvin only. Now, students, you can just cancel here. This 3R and this 3R. So, what students you can write over here? This is 320 and mass in fact mentioned, but this thing already we know what is the mass is. So, what students you can write? This is 32 is equals to beta. This is T we wish to find, and this is mass is 2. Now, we just do simple calculation beta. This is what 16. You can say 16 beta, and this is what you can say 20, just squaring both of the sides. So what beta will get here? T is equals to 20 Kelvin. But answer beta we suppose write in degree Celsius. So what we can do, bacha? For final answer, temperature, this is what you can say beta is 20 minus 273. So you will get minus 253 degrees Celsius. Hence options B is correct. Now, students, have a look next questions. So, what's question next, student? You know, mu is mentioned. It's a, I can say, class question. It's a, I can say, special case of prism. There are three cases of prism in which they ask case number. I can say this is second basically. Every teacher discuss this. I can say concept in the classroom. It's a true. Now, students, I can say what mu is mentioned. Mu is, student, this is the refractive index. What would be the angle of incidence for a light ray such that emerging ray grazes out? That is student point. You know what's there in the questions? Light, this is you can say incident light. Students, you can say this is incident light. Now, beta, this is a refractive index of prism is mentioned. I can say this is what root 2. What's in the question, student? Ray will go like this, and ray is what? Emerging, grazing. Students, ray is basically what beta I can say grazing. Students, ray is grazing from here, right? So you know beta, what is the condition? It's a what? I can say ray is going beta at this conditions. So we can apply this is what? Ray definitely will fall. Rays finally is what here at critical angles. Student, we can find here what is the critical angle. Sine C is what beta? This is NR upon ND. NR beta we can take for environment. That is what one only. So students, you can write sine C. NR is what? 1 beta. and ND, this is what? Root 2. So finally, you can say critical angle value, that is what? 45 degree. Student, this is a 45 degree, right? Apex angle beta, this is what? You can take 90 degree. So what is apex angle basically? Or angle of prism? You can see this is what? R1 plus R2. Students definitely will get R1 is what? I hope all of you remember basics of the prism. So this is R1 beta, you will get 45 degree. This is 45 beta, so what we can say, angle of incidence must be what? 90 degree. So this is what, my dear, angle must should be 90 degree. So you can say options 90 degree is the correct answer for these questions. Right, student? Now have a look at next questions. Now, students, what's the next question? Question number 6. Student, data can be changed. Just keep in your mind. It's true only. Now, student, what question says? The total length of potentiometer wire AV is 50 centimeter. Okay. In the arrangement as shown in the figure. Beta, what's the next? If P is the point where the galvanometer shows zero reading, or you can see zero deflection, then the length AP, it's a, I can say beta, it's a very common and very simple numerical they asked. Beta, just keep in your mind, this is what I can say basics principle of I can say potentiometer wire. Beta, let us suppose you are getting a deflection zero over here. I'm calling this is X. And what's the entire length? This is 50. So now students, you can say this is what basically 50 minus X. This is what you can say 50 minus X. Now, beta, this is the theory you can apply. This is the I can say wire. For wire, what we can take resistance. Lambda we are taking for linear mass density. So resistance you can write what it says lambda into x. So let us suppose I'm calling R1 students. This is R2 student. This is R. I can say R1. This is X1. This is R2. This is X2. So student, you can apply basic principle. So this is what R1 upon beta. This is x into what here? Lambda is equals to, you can write R2 upon beta. This is 50 minus x into lambda. Now, students, you can say lambda cancel. R1 beta mentioned, you can take 6 upon x. R2 student, you can take this is 4, 50 minus x. Now, student, just do cross multiplication. You can say step 1. Now, student, it's step 2. What is student? This is 300 minus 6x is equals to beta what we can say 4x. You can say 300 is equals to 10x beta. So x this is 10 cancel. So x will get this is what I can say beta is 30 centimeter because they are asking about answer in centimeter only. Hence, students, you can say option number C is correct. Now, students, have a look next questions. Oh, this is question number 7. Already I explained here only. This is question number 7, student. Already I explained. Now, students, have a look next questions. No, it's literally very most repeated questions in JEE, my dear. Right? Students, more than 2 times repeated. Exactly, I'm forgetting what's a year usually, but they ask more than 2 times this question. Exactly, data will be just little change left and right, but concept remains same student for solution of the questions. So I can say strongly recommend to each and everyone, student be punctual, do more PYQs, and try to do a variety of questions cover like pattern of questions which already asked in NTA. Students, have a look of these question solutions, right? So, student, what is the solution for this question? Vita, if you have a basic idea about, I can see semiconductor, that is, I can say diode, right? Vita, diode will work if I can see this terminal P junction is what directly connected to positive cell. That is the basis point, my dear. So this point beta will work because this point is what directly connected to positive cells, right? Now beta, this will not work because this is what anti connected to beta. What I can say this cell. So you can beta forget for this solution to question students. You can forget this one. Beta also mentioned the question. We have to find, my dear. for the condition of what? Steady state, right? If condition is been mentioned that is steady state, then what you can say, my dear, again beta, there is no contribution for this circuit. There is no contribution of this circuit, right? So beta, for this condition, you can is forget. Just you have to forget. It's a literally very good question. There is a probability they can repeat again. It's a very good question, student. Now, beta, you can say just you have to forget and just again make one more phrase diagram, my dear. Students, you can just make one more phrase diagram, right? Okay, beta, this is 4. This is 1, my dear. This is what? 2.5. So we wish to find what is the charge, right, on capacitor. So first we can find beta current over here. So we can say this is what? First, before finding current, we have to first find R equivalent. 4 plus 1 in series beta, we can write this is what? 5 ohm. Now, bacha, this is R equivalent. What is I beta? This is what? You can say V by R equivalent. So what is V? 2.5 by 5 beta G. So this is what? You can say 1 by 2 ampere. Now, students, just do one thing. What is the drop over here? Because we wish to write charge. Students, you can see this is step 1 and step 2 beta. We wish to find charge on capacitor. So what we can say, Q is equals to CV. If Q is equals to CV, my dear, then you can say C already known for us. That is what I can say with 5 microfarad. So you can say this is a 5 microfarad. This is what, my dear, 5 microfarad. Okay, we wish to find V. Students know for V, what you can say, we'll get what is the drop on this resistor. What is the drop of this resistor? We'll get same drop over here. Why? Because there is a capacitor basically. No, this is the resistor. There is no work because time zero at steady condition beta. This will act as a what open circuit. There is no contribution of R. I can see for flow of current in the circuit. Then beta, what you can see, what is the we are getting potential drop over here. So you can write V is equals to IR. So what is I, students? This is 1 by 2 and R is 4. You will get this is a 2 volt. So this is a 2 volt Bachaji. This is a because these are in parallel. So you can see this is the potential drop we'll get over here as usual. So this is 5 microfarad into 2 bacha. So what we'll get? 10 microcoulomb. Hence, students, you can say option first is correct answer. Option first is what is correct answer. Now, students, have a look next questions. What is questions number 9, students? That is again, it's a most repeated questions in the classroom. Jay also repeated and also myself repeated more than times for everyone so that we can easily solve in the paper hall as well. So what is the solution student for these questions? Have a look once. Mass student mentioned that is 2 kilogram. Displacement as a function of time also mentioned students alpha, beta, gamma that is 1. We have to find work done what? I can say t is equals to 2 seconds. What? T is equals to 3 seconds. Now, students, I can write work done is what? It's nothing but change in, this is the first click, students. This is the first click I can see to solve these questions and to kill the question beta. Change in kinetic energy. What is work done beta? You can say half m into beta. This is the dimension. You can write v final square minus my dear v initial square, right? Okay. Then beta, you can say this is what? Half. This is beta, you can write half. How about Chaji? This is mass, you can write 2. V final v initial, we have to find separately. Now, students, I'll just solve in step 2. This is already mentioned. X as a function of t. I'll differentiate one time beta. I hope all of you also know. This is students alpha t square plus beta t plus gamma. Alpha, beta, these all are one, so you can ignore. Now, student, for getting velocity, we have to differentiate one time. This is dx by dt. What are students? You can see this is 2t plus 1. This is constant. This is, you can see 0. Gamma goes to 0. Now, students, you can find because what is the Vincent timing? 2 seconds and 3 seconds. Students, you have to find t is equals to 2 second beta. So this is what? 2 into 2 plus 1 beta g. This is, you can write 5 meter per second. Now, students, because also we have to find velocity at t is equals to 3 seconds, which I can put over in this equation here. 3 beta. So 2, 3 the 6 plus 1 beta. What we can say? 7 meter per second. Now, students, this you can fit our value. So what's the V final? 7. 7, 7 the, this is 49. Minus beta g, 5, 5 the 25. So, beta, this is cancel each other. 49 minus 25 beta. How much beta? Tell 9 minus 5. This is a 4. And this is beta. I can say 24 joule. So this is answer beta for this question. It's a very common question, students. You can do. Yes, beta. Very easy. Very easy beta. Very easy. Good. 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 Which question I explain again, students? Just you can highlight. This is questions number 9, student. This is questions number 8. Which question I have to do explain? I have to explain again. Please tell. I'll explain beta. Okay. Now, students, just have a look next question. Questions number 10. Students, in question number 10, what says mass beta that is mentioned 6 into 10 to the power minus 27 kilogram, charge 3 into 10 to the power minus 19 coulomb, potential beta that is 1.21 volt. Find the de Broglie wavelength of charged particle. Okay, students, for this questions, it's again, I can say very superhero for the Broglie wavelength from modern physics. This question from modern physics here, I'm just forgetting to just tell you which questions from which chapters. Now, students, you can write this is lambda is what beta? H upon mb, right? If you remember, you had one relation. No, beta, I didn't see these questions in, I can see today, shift 1 and shift 2. I can give you, I can tell you, we remember this question. You will read this question definitely, 100%. So what is the relation beta? I hope all of you remember. Kinetic energy, you can write beta as P square by 2m. So beta, you can write P is equals to what? 2m into kinetic energy. Beta, there is one more relation here. I hope you remember. Beta, as a kinetic energy, you can write here. That is what? Q into delta V. You know, beta, from here. Beta, you can write these equations if any charged particle accelerated through V potential. Then what beta I can say? Potential energy, initial energy of the charged particle converted what in terms of kinetic energy beta. No, beta, it's chemistry, you can say, student. Chemistry, you can say, it's very, I can say, common. But usually beta, I can this question design in physics. You can tell students. Yes, beta, I'm solving today's the against paper, students. I'm solving beta. No, this is the second attempt beta. Student, I'm discussing this is a attempt to two question paper beta, not a first attempt. This is the second attempt, students. Maybe in chemistry beta, but in physics, this is questions came student in JE means shift two only. So beta, this is you can convert beta. You can just apply this energy over here. So student, momentum you can write. This is 2m q into what was charging delta v. Mm, beta, I'm little slow in chemistry here. Uh, this is beta. Momentum is v beta, right? So beta, I can see this. You can write this one h and mb is what? Root of 2m q into what which is delta v, right, students? So I can say beta lambda h beta. Everything mentioned for us. You can just read and we did answer. H beta you can take 6.634 10 to the power minus 4 beta 34. Then beta, this is what you can get twice mass is mentioned beta is how much? 6 into 10 to the power minus 27. Charge particle also mentioned student 3 into beta is 10 to the power minus 19. Which chapter, sir? Beta, this question from modern physics, student. Student, this question from modern physics. Yes, beta, you correct. You correct, beta. You correct, beta. This is beta 2 mass I have taken beta mass is mentioned. Charge is been also mentioned and potential beta that is 1.21. So beta you can just multiply 1.21. Punishment, you can solve, you will get answer. Okay, students, you are in 11th class. Okay, then wait. Students, just now I have solved. Wait, wait. Stay here, student. I'll give you. I'll solve 11th question. I'll tell 11th and 12th question, students. So this is the student. I can see question from 12th class, modern physics, right? So now have a look at next questions. What we done? What is the next question? Student, this is questions. I can say either from 11th class, you can say from gravitation, or purely you can say from 12th class electrostatics students, right? So what's the question says? Two spheres having equal mass m, charge q, and radius r are moving towards each other. Both have a speed u. Oh, I'll help you, students. We shared Physics Point. Physics Point is a platform in Pan India, just guiding those candidates who has a lack of confidence, right, students? So you have to just connect. I can say Telegram channel of Physics Point. I'll guide you personally. I'll guide you personally, beta. Okay, student, please write in English. I'll help you, beta. You wrote something, sir. कुछ No, no, no. I'll help you. I'll give you free class of physics. Don't worry. Student, I'll give you free class of physics. Stay in meeting. Stay in the meeting, right? I'll give you free class of physics. Definitely will improve. Ah, yes, yes, beta, you can do. Just be regular student. Just stay in the meeting, beta. You will do, beta. So, beta, here we have to find what is the minimum value of u. Students, what we have to find minimum value of u. So, beta, it's very questions. I can see it's based on 11th class. I can say concept beta I'll apply for 11th class students. Beta, God bless you. Students, I'll apply the concept from 11th class, but literally questions designed for 12th class, right, beta? So, beta, what's the thing? Initially particle has a kinetic energy. Collision, I'll teach you, beta. I can say, beta, I already uploaded a few videos on collision. But if you wanted a student, then I'll arrange live class, right? Just you can just mention your queries, students, on comment box because I uploaded many videos. Students for 11th class, especially students, I already uploaded fluid statics because the students fluid statics, someone asked, sir, it's very tough. So due to this student, I uploaded many videos. You can go and watch. If you are, if you feel any like doubt or anything, just you can mention your queries in comment box. I'll back to you, right? So now I'm targeting 11th class more student because 11th class maximum I can say getting the student got confused. Either I can say core chapter like rotation, center of mass, like basics of work power energy, fluid statics. It's a very major and toughest topic of 11th class. Due to this student, I started to upload the uploading the lecture. I'll upload a lecture day by day, right, students? Yes, I'll upload the students. I know 11th is literally easy. Student, I can tell you about my result. No, no, no. Student, I'll help you. Student, my one kid, I can say he secured in JEE Main 2024, JEE Main student 2024. 100 percentile, 100 percentile in physics. In section one student, he got 80 marks. In sections two, he got 20 marks. Finally, beta, he got a college. Now he is in which? No, 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 beta. Beta is he got IIT beta, right? IIT Roorkee. IIT beta, IIT Roorkee. IIT Roorkee beta, right? Uh, students, okay, students, you can do just stay at Physics Point. As I said, Physics Point is a platform where you will get personal care. Ah, yes, yes. Then you will do. Then you will do. Then you will do. I'm looking those kind of candidate only who wanted to do hard work. I'll help you, beta. I'll help you, student. Don't worry. Just stay. I'll give you personal information of Physics Point, how you can connect. I'll arrange classes, everything for you. You can do, bacha. Now, beta, I can say for next questions. What bacha ji? Student, can I discuss the paper, please? If you'll allow. Students, should I discuss the paper? Okay. Yes, beta. Just you can just connect, beta. I'll help you. Now, beta, so you know, particle has the initial kinetic energy, right? Okay. Yes, beta. Very good. Students, I can say particle is what? Both moving each other. So what you can say, particle students has, I'll go little slow, beta. It's a part of 11th class, come 12th class. So particle students has the initial kinetic energy, right? If particle has the initial kinetic energy, beta, then what you can say, this kinetic energy, what this says in the questions, students, what's the minimum value of u so that they touch each other? Mean they will not collide, they will touch only. Okay, fine. So if they will touch here, then what you can say, this is loss in beta, particle has initial kinetic energy. Loss in kinetic energy is equals to what, beta g? Gain in what, beta? What is energy? Simple. So what is initial kinetic energy, beta? You can write half m beta g. This is u square. But beta, don't forget to just multiply by 2 because there are two particles, students. There are two particles, students. Now, beta, just don't forget to multiply by 2, beta g. Gain in potential energy, bacha. So what is gain, bacha? What is the potential energy formula? I can write here for 11th class student. I'm writing, beta. Potential energy, beta, for a pair of charged particle. Formula potential energy for a pair charged particle, beta. This is K Q1 Q2 by beta R. Right? This is one formula which I'll use only. There is no any country. 11th class you can understand. 11th class you can easily understand beta G. Right? So beta, what is no beta, that is which we wrote student MGS. Beta, that is gravitational potential energy. Beta, here I'm writing potential energy for a pair of charged particle. So student, this is the formula. This is the formula potential energy for pair of charged particle, beta. So I'll apply, beta, here only this formula. So what, beta, you can see both have an identical charge. You can say, beta ji, this is kq square by what? This is, beta, 2r because they will touch. So what is the final radius? R of this and R of this, beta. Initially what? Finally what we can say? 2R only. Initially what's the difference? Distance between these two center, beta, 4R. So you can write over here minus KQ square by 4R. Right, my dear? Okay. Yes, beta, between two charges. Yes, beta, between two charges. This is, beta, formula you can apply. If we have a charge particle, you can say, my dear, this is Q1, this is Q2, and beta, both are at R. Then, beta, you supposed to write potential energy for a pair of charged particle K Q1 Q2 by R. What, my dear? K Q1 Q2 by R. So this is a beta condition which you can keep in your mind. Right. Okay. Beta ji, here, what you can say, just beta, just do simple beta. This is two, these two cancel, student. You can write mu square is equals to what, beta? Just take LCM this. Then beta, this is, you can say 4R only. So this is 2R, beta. So what you can write? 2 KQ square minus, beta ji, KQ square upon 4R, beta ji. Then you can say what? uh, m u square is equals to, beta, tell everyone, 2 kq minus kq, beta. What we can write? Kq only. Yes, beta. Exam. Oh, tomorrow is my J exam shift 2. Friends, then just I'm telling you, revise today paper shift 1 and shift 2. Students, shift 1 already I solved live discussion, right? Now, student, I'm just solving shift 2. Stay connected. I'll try to do all the questions, student, which is maximum possible from my end. Beta, I can write this is kq square by beta g 4r. Baby is to find u beta g. Then you can say u is equals to, beta, this is k q square by beta m 4 into r. The students answer in terms of, we can use students here. K is equals to, sir, we use F is equals to, yes, beta, that is a gravitational force, bacha ji. Okay, sir, what is suggestion you should give for tomorrow exam? Students, I can say uh, you got jelly beta, but don't worry. By tomorrow, I can say just do paper only. Do today's shift paper, shift one and shift two. That is more than sufficient, beta. Beta ji, that is more than sufficient. That is more than sufficient. Student, you can feed this value over here. Then beta, you will get u is the speed of the particle. Just will not collide. Just will touch each other. Beta, how much? This is q square by 16 pi epsilon naught m into beta r. So which option is correct, student? This is options number first. Options number first. Sir, I can't able to solve this question. Okay, I can see beta for in 11th class. No, don't worry. Be cool. You are now just connected to physics mind. I'm telling you, many person is giving explanation on YouTube or like beta just availing online tuition. But you have just, sir, I let something, some point you can live with that. I'm in line ninth, but understood the solution question. Oh, very good, great, great. You can understand because always planning to do anything according to student expectations. So we can learn better. Very good. Now, friends, have a look next question here. Beta, what says in the question? A capacitor is initially connected to a battery of EMF E and capacitance beta C. If capacitor is disconnected and reconnected across an inductor, very interesting and very good question, students. Very good, sir. He understood the question, sir. Okay, okay, fine. Okay, students, just have a look here. Attention here only, beta. I can say, Bacha ji, what's the solution of this question? Student, it's no, it's a, again very good question. Student, it's a very good question, students. So, what's the thing, Beta ji? I can say, the question says, let us suppose you have a capacitor initially. My dear, it's a capacitor initially. It's a charge. What these students after this connection, they will reconnect again. And this is what, Beta, you can say this is the inductor. This is what, my dear? Capacitor. Yes, no, beta. I can say this is a beta designed easily. You can connect students from alternating current, my dear. Beta, here I'll apply concept of alternating current, bacha ji, right? So, beta, I can say especially designed for alternating current, beta. There is just name of capacitor only, bacha. But student basically questions dedicated to alternating current, bacha. I hope you got my point. Now, bacha, what you can see for this question, beta ji, because initial charge is what? Beta ji mentioned. No, what is the major point for this question? Student, what is the major point for this question? The what mentioned? Inductor. The 25% of what energy is transferred to the inductor at a time t. So we wish to find the value of time only. Sir, beta, it's a, I can say 12th class. It's a 12th class students. In JEE means this year. Okay, okay. Now beta. So, student, just I'm giving you one result, right? Charge as a function of time t. So, beta, I can say this is the result I'm writing from alternating current, AC students only. Q is equals to what? Q naught. This is cos omega t. Beta, they mentioned here, there is what? Decrement of 25% energy. You can write as one, this is Q naught by 4 is equals to Q naught beta g, and this is students cos omega t. Now, students, you can see Q naught cancel. Students cos omega t, you can write 1 by 4. Students, you can write omega t is what? Cos inverse 1 by 4. Students, no, there is one point what saying in the question. They connected to inductor. Students, I can see it's a relations in alternating current. It's a very heavy. Omega is what, beta? You can write over here. That is what, bacha ji? Omega is equals to root over LC. Omega is what, beta? 1 upon root over LC. Right, my dear? We wish to find time only. So what we can say time, bacha? You can write in this step, bacha. This is step 1. This is step 1 finishes student. This is, you can say, step 2, my dear students. You will give this kind of solution at the physics point only, because physics point only emotion of parents and students. So T beta, what you can write, this is cos inverse 1 by 4 upon beta g omega. So T beta cos inverse 1 by 4, and omega is what beta? 1 by LCR. Simply can multiply beta g, right? So this is, student, you got answer for what? I can see this question. This is the time, students. This is the time, students. Omega is one of the solution of the cube of unity of maths. Okay. Now, students, have a look next questions, beta. What's the questions? I can these questions you can connect from ninth grade. If you're preparing for competitive examination, then you can also connect from sixth grade, right? So it's a easy question, students. You can do. I can say Shreyans. Shreyans, am I calling Shreyans? Shreyans, maybe in 11th class. Shreyans, you can should connect this question easily. So student, have a look of the solution of this question, beta. Right. So, what's the thing, Vitaji? I can say, what's in the question? Are equivalent. Just go, students, little slower. Are equivalent, beta, mention this is what? I can say X, you can take beta X ohm. So the full page. Okay. Very good, beta. Is it fine, student? Is it fine, student? Yes, Shreyans, beta. Are equivalent. Yes, Shreyans, correct, Shreyans, beta. Now, beta, what you can do, beta, you can initially connect. These two are in what, beta, ji? Series. First, you can connect a student. This is the series. Now, beta, finally, what? You can see in parallel. So, series, beta, just you can add first. First, beta, I'll find R equivalent. So, this is what, students? 2R plus X. You can make, beta, one diagram like this for betterment. 2R plus X, beta. Now I can say this is what R. Now, beta, I can apply here, which you wrote the formula Shreyans, 1 by R1, 1 by R2, right? So, beta, what I can say, beta, this is a formula here. If we have a two resistor in parallel, then you can apply beta R1 into R2 upon beta G R1 plus R2. Right, beta G. So here R equivalent beta mentioned the question, which is equals to X, and R1 beta. This is 2R plus X into R upon beta G 3R plus X. Just beta do cross multiply. 3R plus X into X is equals to beta 2R square plus RX. Right, my dear? Okay. Here beta, what you can say, this is 3RX plus X square is equals to beta. Is it fine? Just be careful during calculations. Yes, beta, correct only. Then beta, you can say this is 2RS squared plus beta g, what you can say? RX only. Do beta just simplify with ya. This is what you can say x square plus 3RX minus RX minus 2RS square is equal to 0 beta g. Now, beta, just do further, student, what you can see? X square plus 2RX minus 2R square is equals to 0. Is equals to what, beta? We can say 0. X beta we can find here. I hope all of you remember formula of X. X is what? Minus B. Minus B plus minus D beta. D is what? Beta, I'm writing here one time formula for everyone. Minus B beta plus minus root of D by 2A. I think 12th का portion is major. No, Syrians, beta, no Syrians, beta. This is a wrong perception, beta. They are asking, they were asked, they will ask equally, beta ji. Now, beta, this is Sira Darachahar's formula. Yes, beta, I heard somewhere, but I never used beta. This is D beta. D is what? V square minus 4AC. D is what, student? B squared minus 4AC. So, beta, what is B square? You can see this is what? 4R squared plus minus beta. This is, you can say, 8r square. Upper beta is 2 only. X beta you can write minus 2r plus minus beta. This is 12 now beta. So what you can say? 2r root 3 by 2. Students, you can say, you can take common 2 from numerator. These two cancel beta. So x, what you can write? Minus r plus minus what beta? R root 3. You can't take minus beta as right. You can take always plus. So what beta answer? Minus r plus root 3r. Minus r plus root 3r beta. This is answer for these questions. Sir, it's 1:30. When you will go for sleep? Friend, just I'll finish discussion beta, then I'll go. Friend, I am the person, no, just always ready to help. So it's a very, I can see demand by students. Sir, you have to upload the solution because your solution literally different. You never left any weak point. That's why student, no, your selection is important here, right? So that, due to this beta, just I'll go sleep. First, I'll finish your discussion, then I'll go for sleep beta. Don't worry. Students, Hindi, I don't know. Hindi, I don't know beta too much, right? I'll try, student. I'll try, student. I'll try, student. Okay. So what's these questions? A block of mass, beta. I can, there is a missing. A block of mass, student. You can say m. A block of mass m is at rest with respect to hollow cylinder, which is rotating with angular speed is what? Omega. Student, it's no. It's a predicted questions in the classroom. In the live class, students, I predicted a maximum candidate during death well concept. During death well concept, I can see in circular motion, I predicted these questions openly for everyone. We remember this question, you will get. Finally, beta, they asked already these questions. What's the diagram, beta? Physics is what? Language of ability. So, beta, be confident on, I can see. Yes, beta, it's a 11th class, Sriyansh. Sriyansh, it's this question from 11th class student. Chapter beta, I can write. This is beta Z chapter. This is circular motion. Students, this question from what beta? It's a circular motion idea, right? Then beta Ji, I can say, what is the things beta, right? It's a detailed concept beta Ji. They said there is what? Hollow cylinder, right? So this is the hollow cylinder. And what's in the questions? Uh, beta, this is the beta. Omega is rotating. There is a body beta. You can say there is a body. This is mass of body is what? M. Mass of body is M. Student, we remember here. It's a very good question, beta. There is a possibility they can repeat this question, student. Yes, sir. Answer 11th class. This question from 11th class. I said circular motion. Already I wrote for you only. This is M mass beta. So, student, I'll make a FBD. This is what FBD of beta mass M only. Then beta for mass here, this is normal force beta. Just be remember, try to just put your mind over here, Shriyans, for learning. Don't be a spam beta. Okay, now beta you can say this is what mass is remains m. Due to mass student, mg gravity force always acting in downward directions. Now students, you can see over here friction is direction of friction. This is what is the direction of friction. Now students, normal always acting beta. Student, normal always acting what? Perpendicular to contact surface. Perpendicular to contact surface, my dear. The student, if anything revolving on a circular path, then centrifugal force always away from the center. So this is center, students. You can write this is what? Direction of beta centrifugal force, which is equals to m omega square r, which is equals to beta, what you can say? M omega square r. Now, students, just equate these two forces because now you can say system is in equilibrium. So, beta, I can write for vertical equilibrium, Students, for vertical equilibrium, beta, what you can write, my dear? This is, you can write friction is equals to mg beta. Say equations number one. Students, here you have to write for this is what horizontal equilibrium, right, my dear? So here what you can say, Bacha? N is equals to m omega square r. Now, students, I'm going to apply condition for students for no slipping. Beta, it's a very favorite concept in NLM. I can say work power energy, circular motion as well. Students, here you can write friction is equals to what? Mu L. Friction is what? Mu one beta. You can also say friction is uh, less than equal to mu one. Both are correct, students. Friction is what beta? It's mg only. So beta, you can write if friction is mg, this is mu. And n is what beta? And you can write m omega square r. Now, students, I can say m cancel. What you will get mu, students? This is g upon what beta? G upon omega square r. This is, students, you can say g. Mu is what beta? This is g upon omega square r. Now, students, so what's your answer? Students, I can see option I didn't write, but this is answer for the question beta. This question from students, I can say, uh, beta, I can say your name. Can you write your name, student? I'll take your name. Don't worry. I'll call you by your name only. Students, just write your name. Mu beta, what? This is answer for this question, students. Just have a look beta. Next, what's the next questions? Student, this question what says? If the distance between the slits and the screen increases, student, it's I can say by DSC. This is a by DC setup. Then fringe width beta. So I can say for this question, my dear, what is the fringe width? Lambda, this is small d by capital D. This is the formula beta. So what's in the questions? Beta Z, this is the question beta. You can just remember what I said beta Z. This is little changes. Lambda, capital D, lambda capital D by beta, this is small d. So beta, what's in the questions? If the distance between the slits and the screen increases, beta, this is I can see screen. Beta z, this is I can see beta, this is the slits we can take. So what's the distance beta? This is I can say beta z, this is the slits. Beta, this is what I can see d. If d increases, correct na student? If you are increasing d, if you are increasing d, so beta also will increase, correct only here. So you can see beta option first it means statement one correct only. Now beta, have a look next. Now students, I can say beta next one. I can say beta this is what statement two. If the wavelength of monochromatic light increases, the fringe width increases. Okay, fine. Student, what's in the questions? Wavelength of light. Student, you can apply same formula. What is the fringe width? Lambda capital D by beta small d. You can write a student. Right. Beta, you can write over here. What's the questions? If you are increasing wavelength, obviously beta proportional layer, then what's the doubt? You can see, my dear, wavelength fringe width also increases. Solution both are correct. Statement first as well as statement second both are correct only. Now, students, have a look. I can say questions number 1-6. Questions number 1-6. Beta, it's question from 11th class, rotation. Students, it's question from 11th class, rotation student, right? It's literally very good question. Very good question, student. Rotation. And I can say important also for those candidate will part of, I can say, next day or coming day with examination. Now, beta, I can see for this question, there is a, I can say some formula student. This question also mention many books as well. I don't want to. call name of any books. So, student, what is the, I can see beta formula of this question. We wish to find what? Basically, acceleration. Acceleration. So, beta, you can write here, acceleration is equals to, this is suppose, you can see beta, support force minus student, this is oppose force. Upon beta g, what you can write, this is inertia, right, my dear? So, beta, here you can say this is the mass. Student, they didn't mention which mass is more, which mass is less, right? So, student, I can say for this condition, I'm taking consideration beta. Capital M is going down. So, this is what? Supportive for the motion. This is what going up beta. So, this is what opposing, I can say making oppose, or I can say not support the motion. So, you can say, but sir, this is A, you can write capital M minus small m upon inertia. What's inertia beta? This is, you can say, capital M means total mass plus beta z. This is what? Small m plus beta. What about? I can say ring. This is what beta? What is moment of inertia of ring? I by r square. Right beta? So you can say I by beta. This is what radius r square. So student, here we have to find moment of inertia first. So beta, here I'll find moment of inertia separately for all. Right students? This is I beta. First I'll write for ring. First, I'll write for ring. So the mass of the four rods and pulley. Okay. So what's the mass of the ring? That is capital M. So what is the moment of inertia of ring? Mr square. So you can write a student. This is capital M. We remember capital M in small m, where we have to write Mr square plus beta g. We have tried for rod. How many rod we have? Two rods. So what is moment of inertia of rod at midpoint? I hope all of you remember. Moment of inertia of rod at midpoint beta z. This is what? I is equals to mr square by 12. I is equals to what beta? Mr square by 12, my dear. Okay. So here beta, you can write, this is, what is the mass of rod? It's the small m. Mass of rod beta, this is small m bacha. So this is, you can say m. And what's the length of rod? R and R. R and R what? 2R bacha. You can say m into 2R whole square by beta g 12. Don't forget to multiply by 2 because there are two rods. In the examination hall, it's a very common error, bacha. So students, you can write I is equals to mr square plus beta. This is 2 to the 4, 4 to the 8, right? You can say beta, this is 2 m r square by 3 beta. 4 to the 8 and 4 3 the 12. I hope you got the point. Now, beta, just do one thing. We used to find I by r square. So, divide by everywhere r square. So, you can say beta I by r square capital M plus beta. This is, you can say, 2 small m by 3. This value you can put over there. Now, students, you can say A is equals to capital M minus small m, beta g capital M plus small m plus beta. This is capital M plus small m by 3. Now, beta, just do here, take LCM. This 3 will goes up. This 3 beta will go up. What? 3 into beta? Capital M minus the small m. This is 3 plus 3, 6m. And 3m multiply over here. So what you can see, this is 6 capital M plus 5 into small m, students. So this is, you supposed to write acceleration over there. There is no option at all. It's a, no, I can say beta, memory based questions here. I hope. Next student, I can say I'm going to solve questions number student, that is 17, right? So what's the beta question number 17? A spherical ball is moving with a terminal velocity 20 centimeter per second. Radius is a ball is 6 mm. Find the terminal velocity for a ball of radius 3 mm made of a same material. Okay, students, I can say it's a highly recommended questions in the classroom. Beta velocity terminal of body 1 upon velocity terminal of body 2, beta, terminal velocity directly proportional to radius square. So you can say, beta, this is R1 upon beta G R2 whole square. Very simple. Given mention, beta, this is 20 centimeter per second. Maybe is to find V2. What is R1 beta G? This is 6. So you can say 6 by 3 whole square. 3 to the 6, 2 to the 4. You can say beta VT2 is nothing but 5 centimeter per second. It's a centimeter. So option B is correct, students. Option B is correct, beta. Now, have a look, students. Next, last question. I can say this is question number 17. It's a student question from, I can say, 12th class, right? What question says, find the magnetic field at the center of a circular loop. In fact, beta, question somewhere changes, but this is a real questions, right? So have a look, beta. I can say solutions. Beta, due to this current carrying wire, what is the directions of magnetic field? You can beta put the finger. How can we take direction? Always you can put the finger in the what? Directions of current, beta. So this is the direction of current, bacha, outward. Due to this current carrying wire, beta G, direction is what? Outward. Due to this, beta G, I can say this. Due to circular loop, beta, what we can say? Inward. Keep in mind, beta. Again, I'll repeat here. It's a highly important. There is a very high probability J can repeat this question, student. How can take direction? Always put your right hand thumb in the directions of current. Right. This palm surface will give you directions of magnetic field. But I can say this is a what? In outward directions. Beta for this, you can say what? In inward directions. So beta, here I'm writing magnetic field due to one. I can say current carrying by what, students? Mu naught into I by 2 pi r. I hope all of you remember direction is what? Outward. Now, beta, this is V2. Magnetic field at the center of circular loop. I hope you remember, everyone. Mu naught into I by 2R. No, beta, this is what in inward. No, this is higher. This is lower. Right, beta? So you can say for these questions, we have to find magnetic field net, which is nothing but you can say B2 minus B1. You can take beta mu naught into I by 2R common beta 1 minus 1 by pi. Just do further simplification. Mu naught into I by 2R. So pi minus 1 by pi. Student, this is answer for the questions. This is what answer for the questions. So I can see which option is correct. Option first is correct. Now, students, it's question from I can say bacha 11th class thermodynamics. It's question from what? 11th class student thermodynamics, right? What says, students? Diatomic gas gamma at 1.4 does 100 joule of works. Okay, student, have a look of the solution, student. Right, what's the work done, beta? This is, you can say 100 joule. Okay, then beta, what's the next thing? It's a what? You can say isobaric process. So beta, I'll use first law of thermodynamics first. Delta Q, delta U plus delta W. Right, my dear? So I'll write for isobaric delta Q is equals to N Cp delta T. Delta U student forever remains same. N Cv delta T. Student, here I'll take ratio of work done upon heat. So this is delta W upon beta delta Q. Delta W beta I'll write from here. This is delta Q minus delta U upon beta. This is remains. You can say delta Q because I wanted ratio. Because why I'm taking ratio? Because work done already mentioned in the questions. Beta 100 joule. This is delta Q. This is delta Q beta. How much you can write? You can write as well. This is N Cp delta T minus NCV delta T upon beta NCP delta T. You can take beta delta T and everywhere cancel. So beta 100 upon delta Q is equals to beta G Cp minus Cv upon beta G Cp. So 100 upon delta Q beta. This is 1 minus Cv upon Cp. It's nothing but what we can say 1 minus 1 upon gamma. So 100 upon delta Q, it is visual. Okay, 100 beta upon what I can say? This is Q is equals to 1 minus 1 by 1.4. Beta 1.4 minus 1 beta 0.4 by 1.4. Beta, further you can solve here, you will get delta Q 350 joule. Hence, beta, option first is correct. Hence, option first is correct, my dear. One more last question, student. Oh, time going to around 153. This is the last question, students. I can say, beta, this question is from 11th class only. Right, it's a very common format of the questions, very common format, student. So what's the thing? Student, again, this is a river. Width of the river is mentioned, student. Distance between the river, that is 200 meter. Students, velocity of boat with respect to river, VVR. VVR mentioned, bacha, this is 10 meter per second. This is what, my dear? 10 meter per second. Right, student? And beta, this is, I can see VR is what? 5 meter per second, beta. Okay. So, beta, first I'll find, what solution, student? What's the thing you can say? This is, students, I can say river. Now, beta, this is the velocity of river, VR, which is mentioned 5 meter per second. Beta, we have to find time taken, right? So, beta, for getting time here, what we can say? Distance upon velocity. Students, to cross the river, beta, we have another velocity. This is what you can say VBR. This is VBR. How much, beta, G? This is, you can write 10 meter per second. Students, these two are 90. Beta, first we have to find time. Just we understand, we try to understand which one is, I can say, applicable here to find velocity. The students, time. For getting time, yeah, this velocity only responsible. So students simply can write for time. Distance is what? 200 by 10. So you can get with a time is what? Basically 10 seconds. Right, my dear? Time is what you can say basically 10 seconds. Okay. Now, bacha ji, 10 seconds. So I wrote wrongly here. It's 20 seconds, my dear. It's basically 20 seconds. Now, students, in second, what they asked, beta, it's a what? Displacement. Displacement is nothing, students. You can write this is a net velocity. So, student, you need to find what is the drift. This drift is nothing but it's, you can say, displacement. Students, I can say, for drift, this is ux into t. What is ux, student? It's ux basically. So what is ux, beta? 5 into, and time is what? Already we got. This is, we can't say beta u, because this is the velocity will responsible to arrive over here. So this is what, beta? Both are 90 degree. A square plus b square plus 2ab cos theta beta. So what I can read, this is what? 5 root 5. What, beta? This is 10 times 100, 100 plus 25. Yes, beta. Hmm. 5 root 5, bacha. So here you can't see use, bacha. Here you can take, beta, z. This is 5 for getting, beta, displacement, velocity net into t. So this is what? 5 root 5, beta. And what is time? This is 20. So what, beta, ji? You can say 100 root 5 meter. This is answer for the question, students. Right. So this is all about your discussion, students. Now, students, I'm going to just stop live discussion, students. All the best, everyone, for your tomorrow exam.